calendar. Let me go over just a few announcements. I don't think any are too urgent for this class, but you may know someone that they are. Okay? Some of these are passed. If any of you are planning to apply for that NASA program, the deadline is today, okay? 2 o'clock Central Time. Well, it just passed. Okay, sorry. Too late. That's over then. That one's over. First Call Quality. This First Call Quality Services out of Indianapolis, Indiana, will be here at our one-stop center just in the Millsap building. That's just outside the loop that goes around this building and these buildings. Pretty big. They're taking applications for the job fair. Quality inspectors, they'll be paying $11 an hour. Team leaders, $13.50 an hour. They'll be there tomorrow, Tuesday, March 6th, One Stop Career Center from 9 till 1. So if you know of anyone, you may be interested, but you may know of someone who would be interested in this. Benefits are available. It's not just that they're paying you a flat thing with no benefits. They will have those. And applicants must have a clear background check, driver's license, high school diploma or GED, and automotive manufacturing experience is preferred but not required. But if you know of anyone that would fit that bill, let them know tomorrow from 9 in the morning until 1 in the afternoon. They can contact Miss Brenda Thomas over there or Miss Dorothy Henry, either of those. Mr. Rassi is still always looking for math team members. They have practices 3 o'clock this afternoon and every Monday afternoon, and Evelyn is here. And they have practices on Friday at noon. So it might be hard for you to make 3 o'clock today, but you could make the the noon on Fridays. Most Fridays. Last Friday they couldn't be because she was at a meeting. I've told you about the tutoring opportunities on both campuses. If you need more information on that, I've got them here. Okay? That meeting's over. That meeting's over. And the graduation. I know none of you are graduating this term, but if you know of someone who is, their meetings are this evening at 6 o'clock on the Birmingham West Campus in the ACAT building, first floor theater. Then tomorrow afternoon at 1:30, they're over here in our Ethel Hall auditorium. And then on Wednesday at 1:30, they're back on the Birmingham West Campus in the ACAT building, first floor theater. Okay, I've got names and numbers if you want to contact people for more information. All right, I think I've marked everybody who's here, who's come in. So let me see, any questions on anything we've covered so far? We're recording. Let me get the slideshow from current slide, and we'll go from there. Any questions? What's that? What chapter? This is chapter 11, 11.4. We're right at the end of 11.4. I gave you your quizzes last time for chapter 11. Anyone who did not get one? Okay. It's a very long quiz. I didn't realize how long it was until I looked at it. I would have tried to make one up. Anyone else need a quiz? Huh? No, it's not hard. It's just long. I usually don't make quizzes that long. But please be working on those as soon as you can, because I'll need to start getting those in. And once I start getting some in, then we'll schedule the test for chapter 11. This is right at the end of what we're going to cover in 11. Write a linear equation given 2 points. Okay? Now, give me a point, any point. Name a point.
1, 2.
1, 6. Okay, how would I plot that point?
Up 1 over 2 to the right.
Okay, say that again. 1, 6. Is that what you said?
I said 1, 2.
Oh, 1, 2. Okay, 1, 2. And how did you say get there?
Up 1, right 2.
Okay. I think I know what's confusing you, whether you realize you're being confused.
Over 2 on the X.
Okay, now that's the second time I've heard recently that I've heard that used. Not quite right. Okay. Now, when you're given an ordered pair, what's always the order?
X and Y.
X, Y. So X is the horizontal axis. So 1, 2 would be 1 to the right and 2 up. Now, I also heard someone, and the thing that I thought I heard you just say, the x-intercept or the y-intercept. These are not x and y-intercepts. X and y-intercept is where a line would cross that. 1, 2 is just a point. Okay? Right there. It doesn't cross either axis. Okay. Now, what if I said I want an equation of a line through that point? A vertical line. What would be the equation of that vertical line through that point?
0, 1.
Okay, that's the point. Okay, 0, 1. If you don't go anywhere here, go up 1. That's not a vertical line through that point. That's a point, a different point. How do you give an equation for a vertical line? Through that first point you gave me, 1, 2. Buckle my shoe. Okay? Vertical line through that point. 1, 1 is another point. Okay? A point is not a line. However, 1, 1 is on that line, but that's a point, not a line.
Y equals 2.
Y is equal to 2. Okay? That would be this line. Y is always 2 there, right? But is that a vertical line? No, that's a horizontal line.
MX equal 1.
Second?
MX equal 1.
X is equal to 1. X is equal to 1. That would be the vertical line that goes through the point 2, 1, or 1, 1, or 0 to 1, or 17, 1, or 8, negative 4, 1, or whatever. That would be the vertical line that goes through that. So a vertical line is always X equal to some number. Now, they put K here. I don't know if that's, okay. It's fine. It just means a constant, okay? And this is Tiana, who I marked you as here when you weren't, okay? So now I will take off the knot, okay? Okay, I'm so used to you being here. Okay. So that's how you do a vertical line, X equal whatever the X coordinate is of the point, any point, okay? Vertical lines, what can you tell me about the slope of a vertical line? Okay, that is correct. The slope is undefined because what can you tell if it's infinitely positive or infinitely negative? It's vertical, you can't tell, okay? There is no run, okay? It's all rise or fall, but no run. Okay, what's the x-intercept of a line y, x equal k? The x-intercept of a line x equal k. Okay. Second? Okay, something 0, but a x-intercept is a point, which is an ordered pair. So I need 2 numbers. Second? Y is equal to 0, so there's the 0. That's the second in your ordered pair.
So it would be 1, 0.
Not 1. In this case, it would be
1, 0.
but it would be K0. Okay? If it's x equal K, it would be K0. Okay? That's why I'm standing in front of you. All right. All right. Now, tell me how to express. You gave me the point 1, 2. What's the horizontal line through that point? Y is equal to 2. Yes, you gave it to me already. What is the slope of that line? Y is equal to 2.
0.
0. It's neither rising or falling. It's a 0 slope. Let's go back to the previous one. Vertical line. X equal K. What's the y-intercept of that line?
0.
Second?
0, K.
Okay? Doesn't exist. If that K is anything other than 0, it never crosses the y-axis. So it has x-intercept of y equal k. Doesn't exist unless k happens to be 0, and then every point is a point. Okay? How about the y-intercept of y is equal to k? Huh? Something is 0. What? Second?
K.
That's the x is 0. And what would the y be? Y equal k. Whatever k is. 17, 2, 45, 2/3, whatever it is. That's what your y-intercept is. Okay? All right. Now, what kind of equation do we call this? Second? Yes, that's the slope-intercept form for a linear equation. And since we're dealing only with linear equations, slope-intercept form. Why do we call it that? Because what? What's the slope?
It creates a slope.
It gives you the slope. What's the slope? M. It's the coefficient of the x. It's always a slope when you're in that form. And what else did you call it? Slope. Intercept form. Why do we call it that? Okay. What intercept do we know?
The x-axis.
The what?
The x-axis.
Okay. It's the one that crosses the y-axis. It's the y-intercept. And where do you see it? That's the y-intercept is 0b. Remember, we always give a point in ordered pairs. And the y-intercept, the x is always 0. The x-intercept, the y is always 0. Okay? So that'll be 0b. Slope-intercept form. Can anyone tell me any other forms we've talked about? Point-slope form. Okay? About another equation we ran across. Say again? Point-slope form. We're going to get there. But before we get there, how do we get the, what do we need to know to get the slope? Slope-intercept form, of course. If we have that, we know it. But if we don't have slope-intercept form, what do we need? Okay. Yes, exactly. Now, what is that between? The point you gave me, 1, 2. Okay? How many lines can I draw through that point? An infinite number. Yeah, I can do the vertical, the horizontal, and any kind of positive, negative slope that I want. I can do an infinite number of lines through that point. So what else do I need to have a second? Another point. So what would 2 points give me to do a calculation with?
Y1 and Y2.
Okay, what are you giving?
This one starts with M, then go parentheses.
What's that?
This one starts with M, then go parentheses, right?
Yeah, you can do, okay, y2 minus y1 over x2 minus x1, what does that give you? Y2 over y1 is a rise, and x2 over x1 is a run. So it gives you rise over run, which is a slope. Perfect. Okay. So here, okay, I had it in the wrong order. Thought they were going to do slope next, but they didn't. Point slope form, you're given a point, x1, y1, and a slope. This gives you an equation of a line. Because what else do you need in an equation of a line besides, say, a slope and a point? You need variables, x and y, and you need, that's it. You need an x and a y, and then the relationship between the others. Okay? So, and the equal sign. To have an equation, you've got to have an equal sign. Remember that. Okay. Now, their standard form, I guess is sort of standard, but it's sure not very useful. The most useful form in my mind is the slope-intercept form. Because from that form right there, very simply written, you can get the y-intercept of the point of the line and the slope of the line. You can draw all the rest of the points you want to from that information. Next to that, a point slope form is pretty handy because there's a point, there's a slope, and you know that's in place. But this tells you almost nothing. Okay?
Why is that?
Pardon me?
So why is that? Why doesn't it tell you nothing?
Why what?
Why doesn't it tell you anything?
Well, can you just look at that and tell me the slope? No. Can you look at that and tell me either intercept? No. Okay, so it doesn't really tell you much of anything. This one you can look at it and say, oh, there's a point, there's a slope. Slope intercept, there's a point, there's a slope, y-intercept, there's the slope. This gets it. Now, you can get it. The slope happens to be negative a over b. Yeah, if I remember that, that's fine. The x-intercept is c over a 0 and 0 c over b. But man, that's a lot of maneuvering to get any information on it. So it does tell you something, but it's just not that useful. Easiest thing to do, get this in slope-intercept form by subtracting a from both sides and dividing both sides by b. That will give you the most information. That gives you the slope of minus a over b and the y-intercept of 0 c over b. Okay? That's, when you look at it, you got more information immediately. No calculations really required. Why they call it standard, I don't know, except it looks pretty, I guess. It looks sort of simple. Okay. Think we're ready for example 8 now. It says, write a linear equation that fits a data set. So example 8 in your book is nowhere close to example 8 on the slide. So let's do the slide first, and then we'll do the book. The table below gives average annual cost in dollars for a medium-sized cup of regular coffee at Muckety Muck's over a 5-year period. Plot the data and find an equation that approximates it. Okay? So, how would you plot these data? By the way, data is a plural word, not singular. And you'll hear people all the time talk about the data is. No, the data are, because it's plural. Okay? But we won't go into that now. Okay? So how do we plot those data? Well, let's first set us up a coordinate system. Now what you notice about, okay, I guess the first thing, whoa, probably drag my computer off the tabletop. That would not be good. I don't know what's wrong with this thing today. There we go. Okay. Don't back up too far. Now, we have probably just briefly mentioned, I hope I have anyway, if not, I'll mention it now, the concept of independent variable and dependent variable. Have I mentioned those before? No? Okay.
More science than that.
What's that?
More of a science than that.
Yeah, but it's math too. I mean, science is applied mathematics and engineering is applied science or applied physics. So they're all connected. Okay? Now, the independent variable is the one that the other one depends on. Okay? The dependent variable depends on the independent variable. So here we have average annual cost in dollars for a medium-sized cup of coffee over a 5-year period. What would you say? Would you think that the cost depends on the year or the year depends on the cost? Yeah, the cost depends on the year because it's been probably rising. Yeah, it's definitely rising. So the dependent variable is the cost, the independent variable is the year. We almost always put our independent variable on the horizontal axis and the dependent variable on the vertical axis. Now, what are some features you notice about these data? Say again? Okay, the price is increasing each year. Was it ever a negative cost? No. The cost is always positive, so you always have things above the x-axis. And what else do you notice? Okay, these, yeah, actually about 25 cents, yeah, okay. But the years are also positive. We don't go backward in time either. So we don't do negative cost and we don't do negative time. So everything's in the, yes, the first quadrant, okay, where everything's positive. So if I'm going to plot these data, I'm going to find my color first, okay, and we'll do the cost axis here and the time axis here. So this is time and this is cost. This will be in dollars and this will be in years, okay. Now, we only have 5 years of data, so that's all we're going to use. So we'll have 0 being here, 5 being out here. So this will be about 2.5. So let's do a 2 and a 3 and a 1 and, whoops, wrong. Let me clean that up a little bit. I just sort of arbitrarily put a 2 and a 3 there. 1 would be here and 4 would be here. Okay, that's about right. Okay. Now our costs really don't make it ever down to 0. We don't have 0 costs on the cups of coffee either. They're always going to be positive. So you could have a little zig in your vertical axis there and say we're not even going to get down to 0. We're going to start this at, say, $2 and go up to $5. Well, 2 to 5 is a difference of $3. Okay. So that would be basically 2, 3, 4. Okay, $2, $3, $4, and $5. Okay. Now help me plot the data. Okay, 2.5 here. Okay. Right 2 and up 3 1/4 approximately, right? Okay. Okay, about 3/4 of the way up, somewhere about right. Well, why isn't it right? Okay, something like that. I may be off a little, huh? 4 and 4 and 5. Okay. And 5 is 5 on the nose. Okay. Now, that doesn't look like it's too awfully far from a straight line, does it? Okay. Now, and it may be just my poor drawing, or it would be exactly. Now, how would you approximate the equation? Well, to have an equation for a line, that's what they're asking for. Plot the data and find an equation that approximates it. What would be an equation you think you might use? Or specifically, what form of an equation? Point slope. Because you don't have an intercept here, because you don't have the 0 year. It starts at year 1. Okay? So you're not given that, so point slope. Okay? Now, which of those probably do we need to calculate first? Point or slope? Slope. You need to calculate slope first. How do we get slope? Pick 2 points. Any 2 you might choose? I would tend to go with the first and the last. Okay? Because unless one of them look way out of line with the others. Okay? So I would tend to go with first and last. That gives you the biggest spread, and you sort of averages out your rises and runs. Whoops. Just gave away too much, didn't I? How do you calculate the slope from there? Okay, we do rise over run. So M is equal to rise over run. Okay, I'm abbreviating like crazy. I'll spell it out. Not that much harder to do. What is your rise? Second? 1? Between those 2 points, I think not. Second? It's 2.5 to 5. See, you go from this point to that point. Okay? And how much rise is that? Second?
3.5.
More like 2.5.
Yeah.
Yeah, okay. So the rise would be 5, the Y2 value, minus 2.5 or 2.50, and the run would be 4. Yeah, 4 on the nose. 5 minus 1. That's 4. Does everybody see that? Okay. What's 5 minus 2.5? I think I just said it. 2.5 over 4. Pull out your handy dandy calculators and see what that gives you. 0.625. That's what we're going to have as the slope. Okay? Now what does that mean? That means on average over these 4 years, 5 years, on average, your coffee is going up 62.5 cents a year. Okay? Let's take a look at that. It went up 75, 50, 20, no, $1.25. Ooh, I didn't plot that one too well. No, 75 and then 50. So yeah, something between 75 and 50 cents every year, 62.5 cents. That makes sense. Okay? And what's your, okay, so now we have the average slope over those 5 years. Okay? Now what else do we need? A point. Any particular point grab your fancy? Okay. Second. That would be perfectly fine. I tend to go with the middle point because then if the rise or run was exaggerated at either end, then you have everything exaggerated.
I picked that one because it's the only one that doesn't have anything after.
Okay, he is really being lazy. I told him he needed to be lazy, but boy, yeah, really, really lazy. Okay, and you can choose any one of them. How about let's go in with the middle? Okay, just because it has something after it. Okay, all right. So, middle point is what? 3.75. Okay, points are always ordered pair. Horizontal, vertical. Okay, so what would be your second? A little louder. 3 3/4. Yeah, if you wanted to use fractions, yeah, you could use that. Okay, I think decimals will do us a little bit better because we wrote that as a decimal, didn't we? So let's write the equation, linear equation. Okay, y, except this happens to be cost. So let's kind of, cost is equal to, wait, I'm sorry. Point slope formula goes how? Cost minus C1 is equal to M times Y minus Y1, or T minus T1. You can use any letters you want to, but I'm thinking cost in years. That way, I'm picking variables that are similar to what they stand for, and that way I'm not liable to say, okay, X's and Y, which one's the X, which is Y? This way I look at it and say, oh, C is cost, Y is year. Okay, I did use, but I put Y on the horizontal. Oh, that's probably a little weird, isn't it? But you can do it. Would you rather use T? T and T1? if that bothers you any, yeah, make it T. T and T1. But you can name it anything you want to. Fred, Sue, whatever, I don't care. T and T1. That way you don't mix up your Y's and X's, okay? Now, what do we plug and chug? C, that's yes in Spanish, okay, minus, second, yeah, 3.75 is equal to 0.625 times, a little louder, T, is that what I heard? Say yes, okay, minus, which one do we use? 3. Okay. Now, let's clean it up a little bit. You know what form I like best? Slope-intercept. So what would you do to, let's first distribute across the parentheses there. 0.625t minus, oh boy, I think that's 8.1875. No, 1.875. Sorry about that. Not keeping up with my decimals well. 1.875. Someone with a calculator, check me out on that. I believe that's right. Yeah. Okay. 1.875. Okay. And then the last thing we'll do is add 3.75 to both sides. I know it's sort of hard to see. That goes away, and you get C is equal to 0.625t plus, yuck, okay? That would be a 5, that would be a 7, that would be an 8, I think. Get out of there. And that would be a 1, I believe. Yeah. All right. C is equal to, approximately equal to, yeah, it's not exact, so approximately equal to, that approximates it. 0.625t plus 1.875. Now the first thing to do is, let's pretend that we are extending that line back here, and looks like this would be, yeah, about 1.8, what was it? Yeah, 1.875, just below 2. That looks about right, okay? Now, what you could do is plug in some of these values, like 1 here, okay? So if t is equal to 1, you would add this to that, and that would be 1.5. Whoa, no, 2.5, sorry about that, yeah. Forgot to have a 1 there. 2.5, look at that, on the nose. Plug a 2 in there. And this would be 1.25 plus 1.875, that would be 3.375 maybe, something like that. 3.25. Yeah, not too far off. Every one of those, they don't come right out on the money. That's why it says approximate. But you see, you get right in the ballpark. Let's use 5. No, I don't know if I want to do 5. Yeah. 4 will be a lot easier to do. 4 times that would be 250 plus 1.875 would be 3.375. No, 4.375. Sure enough, that would be close to 450. So you see, you're not exact, but it approximates. A pretty good job. Okay? Let's see how they did it. Okay? They go back to X's and Y's. I like to use letters that remind me of what I'm talking about. Let Y is equal to the cost in year, the vertical axis, in year X, which is the horizontal axis, just like we did. Okay? Then they plot their data, and boy, that doesn't look too far off from what we did, does it? Okay? So let's see what we get then. The points appear to lie approximately on a straight line, not exactly, but approximately. We can use two of the data points and the point-slope form of a line to find an equation. So they chose the first and the last. How clever of them, okay? Because you get the widest range you see. Now, if one of those was way out of line with the others, don't use it. Use two as far apart as possible, but seem to be along the same line. All five of those were along the same line. Okay? So your slope became 5 minus 2.5. That's your change of y's, or your change of cost, over your change of x, or the change of years. That would be 5 minus 1 is 4, and that gave us 0.625. Okay, we'll use the 0.55. So they did like Daniel was suggesting. They went to the end and used, because they were lazy too, and they didn't, okay. All right, 5. I chose to use the middle one, okay, with a slope of 0.625 in the point slope form. So y minus 5 is equal to 0.625 times x minus 5. So that's y minus 5 is equal to 0.625x minus, and you see, even though you chose one with none, it still has 4 digits in it, 3.125. Add 5 to both sides, and you get 0.625 plus 8.75. Oh, I already erased mine. Sorry about that. Isn't that awfully close to what we got, or is it exactly? It's exactly it. So you see, it does matter a little bit which point you did. We happened to choose 2 points. They chose one, we chose the other. Happened to be right on the same line with each other. So yeah, there it is. Make sense? Okay. And people use this all the time. I don't think I told you all this story yet. My younger brother, did I tell you this? It was a vice president. He's retired now, but vice president of a small electric power company in the rural area of Georgia. And part of his job was every year he projected, he took the past 5 years of data and he projected what the trends were. What was our customer base? Was it going up, going down, steady, whatever? Anyway, it took 5 years. What was the cost of the electricity? Because they had to buy their electricity from Georgia Power or from the manufacturing of it, and they had to estimate cost. So he had the cost every year. He had equipment, personnel, everything he projected for the last 5 years, and then he put them together in what he was projecting the next year to be. Only 1 year past that. And so he was doing the same thing we did here, only we were looking at 5 years in, he looked at 5 years back and projected, because every year they had to go to the Public Service Utility Board, or whatever they called that, Public Utilities Board, that may have been it, and request either a rate increase or maintain the same rate. I happened to see in the last newsletter we got, because we have a small bungalow over there that we buy the electricity from, that company, that they were actually decreasing the rate this year because they had very favorable past few years. So I don't know if Dan ever decreased the rates. He would fudge it, so it always would stay the same or add a little bit, but they actually decreased it that year. So yeah, people use this all the time in projecting. Okay? I use it when I'm, I don't actually formally do this, but when I'm projecting how many books for the bookstore to order. I look at how many books we had last spring, how many books we used last fall, okay, and project that for next fall, see which one came out reasonable, okay, and usually I use fall to fall more. So I can make sure, at least, not sure, but, you know, reasonably certain we'll have about the right number of books on the shelf, you know. But then the bookstore turns around and say, well, we didn't, students didn't buy that many last year, so we're going to bring that down a little bit. And sometimes they mess up, and sometimes they do okay. Now, notice here, in example A, if we had chosen two different data points, we've got slightly different equation, because if you chose not the endpoints, but two in the middle, they may have been slightly different slope and also slightly different. We didn't call it that, but it was a y-intercept. Okay, so let's back up from there. You want to see the other one? Okay. The one in your text, the table on the margin, in the margin, lists the average annual costs in dollars of tuition and fees for in-state students at public four-year colleges and universities for the selected years. Year 1 represents 2001, year 3, 2003, and so on. Okay? Plot the data and find an equation that approximates it. Okay? Now, if you'll notice there, they used years that were 1, 3, 5, 7, 9, and 11. So they had 6 data points, but it was every other year, the odd years. Okay? Their cost, surprise, surprise, was a little bit more than coffee. Okay? $37.66, $46.45, $54.91, $61.85, and $82.44. Okay? Plot the data and find the equation that approximates it. Okay? Again, what do you notice about these data? They're all positive. The years are positive. The costs are positive. Yeah, they didn't pay you to come to school that year, okay? No, you paid them to go to school that year, all years, okay? So, we will set up just the first quadrant of our graph. And again, I like to call this cost in dollars, and this will be time in years. Okay, and where each year represents that plus 2,000. All right, so this will be year 0, 2000, and this will be 2011 out here. Now, halfway in between that would be 5.5. So let's make 5 there and 6 there. Halfway in between that is 2.5, so let's make 2 there and 3 there, 4 there, 1 there. Halfway between goodness gracious, I'm going blank now. Let's do something like, wait, 2, 3, 4, 5, 6. I think I messed that up a little bit, but we'll go from there. Let's see if that works. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, that works. Okay. So there's our years. 1, 3, 5, 7, 9, and 11. Okay. Now the costs. Let's have those run from 3,000 to 9,000. So we're not going to start at 0. We're going to start down here at 3,000. I'm going to put 3K. and go up here to 9,000, 9K. Okay, and these are in dollars. So that's 6 in between that. So right, that would be 6,000 right here. And there would be 4,000, 5,000, 7,000, 8,000. Okay, just estimating. Okay, so 3,000, 4,000, 5,000, 7,000, and 8,000. Okay, so let's plot these. Year 1, 3.7 approximately. So 3.7 would be right about there, about 3 3/4. Okay? All right. Year 3, 4.6. That would be just over 4.5. So that would be about there. Okay? 5, 5.5. Right around 5.5. Right about there. Okay? 7, 6.2 approximately. Just over 6. Okay? 9, ooh, I left off something. Oh, I messed up. Thought that seemed like a pretty big jump. Y'all aren't keeping track of me, okay? I skipped one. 70, 50. Come on. 70, 50, and year 11 was 82.44. Okay. Goodness, my eyes suddenly have gotten really dry. That happened about midway through my class this morning. I mean, my eyes got so dry I could hardly look. Okay, 5, 7, 9, 70, 50, so just over 7. It would be about there. And then 11, 8.2. Something like that. Okay? It's a reasonably solid, I mean, not straight line, but, you know, can be approximated with a straight line. Okay? Now, we plotted the data. Tuition, in-state students, public 4-year schools and universities for selected years. Year 1, yeah, we got all that. Okay. Plot the data and find an equation that approximates it. How do we find an equation? Point slope formula. And how would that read? Okay, y'all like to go back to y's. We can do that. Okay. Okay, y minus y1 is equal to m times x minus x1. Okay? Now, what do we need to fill in there? Okay. What point would you like to use? Second? Do you like to use the bottom one? That'll be fine. We'll use it, but frankly, I would go with either 5 or 7. And looking at my data, they're both sort of wacko. 5 seems a little more in line than 7, but I may be wrong because I'm not plotting very neatly. Okay? But you can go with the bottom one. That would be fine too. Okay? So we're going to use this point because Greg Joy said to. Okay? And we know the coordinates of that point. Right there they are. Okay? So, what else do we need? Slope. How can we get that? Okay. We have m, the slope, is equal to y2 minus y1 over x2 minus x1. Now, what do we want to be our y2, y1, x2, x1? Again, I would tend to go with the endpoints. Now, The one thing that's a little bothersome, especially looking at the one in the book, looks like, and especially looking at the data here, notice it's 3, 4, 5, 6, 7, 8. So not far off. So I think any one of those would do, except this seems to be a bigger jump here than you had at most of the others. See, this is a little less than 1,000, less than 1,000, less than 1,000, less than 1,000, 1,200. Okay, so you might want to choose these two here. Except if you're doing anything to project toward the future, that may give you the best idea of where it's going from there. It looks like it's going to take off and go. So you might want to use that last one. It doesn't matter to me what you want to use. We're approximating after all. So what are you going to use? Help me, help me. Which one? Okay, that'll be which? So,
3766.
okay, and what? Oh, that's what you're going to use first? As Y2? Is that right?
Sure.
Huh?
Sure.
Okay. 3766 minus which one? You want to use 4645? Okay, I mean, you can. It's fine. But if there was something abnormal here, that may throw your whole slope off. Now, I'm not saying it looks like it is, but looking at the data, I would either go with the first and the last or the first and next to the last, just because it looked like that was more in line. But, like I said, if that last one shows you've got an upward trend going, then the last one might be the better one to do.
Okay. So
You choose.
44.
Second?
8244.
84, 244. He's going to go with the last, and that would be 8244. Okay, and then what you put in the denominator?
Would be
1
11.
minus 11. Okay? Now, by choosing this way, you get negative numbers. Okay, we can handle them. That would be
Negative 4,478.
4,478 divided by negative 10. Negative divided by negative is positive, and that would be 44, 7.8. Okay? Just move the decimal one place to the left. That would be your slope. Okay? So then you have y minus. Now, we only need 1 point for the point part. What point do you want to use? First one, okay, that'll be fine. Frankly, I tend to go with one more in the middle, but first one's fine. So we'll do y minus what?
3266.
Second?
3766.
3766 is equal to m, which is 447.8 times x minus 1. The x is always in there. You got to keep your variables. To have an equation, you got to have variables. Okay? So this will be y minus 3766 is equal to 447.8 times x minus 447.8. You just distribute this into both parts of the parentheses. Now what? Add 3766 to both sides. Okay, and what does that give us? Y is equal to 447.8 x plus, no, that's a minus there, plus there. 3,000 300, 1.
3,318.2.
Second.
3,318.2.
Yeah, 3,318.2. Okay. Now, that's our guess. Let's see how they did. They used their slope. Whoa! They used a very different slope. They used points. Oh, they used two right next to each other near the middle. Okay? And by in so doing, well, I don't like their choice, but it's fine. They got a slope of 347. We got 447, 448 approximately. And then their y-intercept was 3756. Ours turned out 3312. Yeah. So when you're approximating, that's what you're doing. Approximating, okay? You don't have the exact. So there it works. They have a problem on the side. Yeah. Okay. So homework exercises. Now they have some of these they call concept checks, and some of them they just have as problems. I would do number 1, the concept check. Wait. Yeah, I'm sorry. I would do all 4 of those. This is page 771, or any of the first 4, because all of them have answers in the back. Then they have identify the slope and y-intercept. This is like example 1. I would do any of the ones 5 through 10. And then like example 2, do any of the problems 11 through 18. Okay? Then do any of the problems 19 through 24. Now my guess is those that have the little dark coloring around, sort of a greenish color. Sorry. I think that means they're in my math lab, but I'm not sure. But if you have it, you can use it. So do any of the problems 19 to 24. Then do any of the problems 25 through 32. Then do any of the problems 33 to 42. And then do any of the problems 43 through 48. Do any of the problems 49 to 56. Any of the problems 57 to 62. Any of the problems 63 through, I say 63 or 64, and then either 65 or 66, and then either 67 or 68. And then they like to go back and relate concepts to previous stuff. You can do some of those if you choose. Any of the odds 69 through 70. Now, any of the problems 69 to 76. Okay. Now, they have some summary exercises here. Now, do these have all the answers in the back, or do you know? I would think so, but let me see if I can find some. Summary exercises, this is chapter 11. And 11. No, I don't see any summary exercises back here. Do you? I'm sure they must have answers somewhere. So try some of those, especially if you need a few more, either one or two or both. Any of the exercises 3 through 10, actually 3 through 18, and then any of the exercises 19 to 25. All right, now 11.5 I had planned to skip. You know, we lost some days at the beginning of the term, weather and other things like that. So I don't think we have time to do 11.5. So we'll move on to, now, any of the ones who just came in, oh wait, remind me to get back to that in a minute. We're skipping 11.5, so just page through that. Then there's a chapter 11 summary, and this is on page 786. A pretty good review of the chapter, okay? Especially sections 1 through 3. They don't have anything for 4, and we aren't doing 5, okay? Then there's some vocabulary type stuff, which is never bad to look at, 1 through 6 on page 787. And the examples, the answers are right below that. And then a quick review, 11.1, 2 sections of that, 11.2, 1 of that, 11.31, and 11.41. Okay, so those are all there. Well worth your effort to take a look at those. Make sure you remember. Then, Chapter 11 review exercises. Now, let me see if I can find those in the back. I'm surely they're back there. Chapter 11. They have solutions and they have answers. I think we're looking under answers. Okay. Okay, I'm sorry. I was looking under solutions before. All of the summary exercises are in the back of the book too, under answers. And then the review exercises are also back here, and all of them as well. So under review exercises, I would do any of the first 4, 1 through 4, any of the next 4, 5 through 8, any of the next 4, 9 through 12, any of the next 4, 13 through 16, okay. Don't worry about 17. That's inequalities. Looks like you can do 18, and any of the 4, 19 through 22, any of the ones 23 through 28, any of the 4, or however many it is, 29 through 34, any of the ones 35 to 37, 38 is good to think through, any of the ones 39 to 47. Don't worry about 48 and beyond.
What page did Chapter 11 review start on?
The what?
What page?
Chapter review, Chapter 11 review, 790 through 792. Okay? And then they have mixed review exercises, which probably wouldn't be bad to do either. That starts with 53 to 56, 57 to 60, 61 to 63, and don't worry about the last 2. Then there's a Chapter 11 test. This wouldn't be bad to look at. Let's see, this should be in the back as well. Yep, and all those answers are given too. Do any of the first 3, any of the next 5, 4 through 8, then do any of the next 3, 9 through 11, then do 12 or 13 or both. Any of the next four, 14 to 17, you don't have to worry about 18 and 19, but try to do some of the problems 20 to 24. Okay, now, one person's leaving, but that doesn't mean we all are. Oh wait, it does, doesn't it? Yeah, sorry about that. I didn't know we had run out of time. All right, please get your quizzes in as soon as you can, and probably, I would guess probably next Tuesday we should figure to have the test. So if you get your next Monday. So if you can get your quizzes in on Wednesday, I can get them graded and you can see what you got before Monday. If you don't feel ready on Monday, we can do it Wednesday, but we got to do it one day next week. Okay?